All right, guys. So we're up to page 10 in our notes. I know we are skipping over some things. So if you had any questions about the transformations that we did, kind of that marble slide investigation last class, we're going to have some time to practice that today and ask some questions. But it's a really important idea going forward because we're going to do a ton of graphing this year without using our calculator. So the BHAK stuff, today is the day, well, I guess next class after watching this video, where I really want you to get good at it, get comfortable with it. It's important to ask questions on that stuff if you're not sure about anything. So right now we're going to extend that a little bit. We're going to go back to something you looked at in past years and see how it ties in a little bit. So vertex form of a parabola. We're going to get to that in just a second. If I asked you to solve for x in this case, I'm going to ask you to pause your video for a second and just think about what you would do to solve for x. All right, so if you haven't paused, do it now. So here's kind of what I showed this to you, what I showed this to you for. Does that make sense? Anyway, so what probably some of you did when you thought about solving for x is you distributed, right? You did x minus 3 times x minus 3. You distributed that out. You solved for x. But we're really kind of set up here already. We're in completing the square form. So all you really have to do to finish this up is take the square root of both sides. So we would have x minus 3 equals, careful here, plus or minus 6. Add 3 to both sides, and we would have our answer. X equals 3 plus or minus square root 6. So use that to your advantage today. Keep that in the back of your mind. When we're solving for x, if we're already kind of in completing the square form, then we should take advantage of that. So just to review, this is an important skill for today. I want you to pause now, and I want you to solve by completing the square. All right, and if you're totally lost, you can just wait for me to show my work in a second, but try it out. I'm going to pause my video and show a little bit of work while I'm paused, and then we will talk together. Okay, so if we haven't looked at it this way together, I think we did. First thing I did was I got the 15, the constant, to the other side where the 0 is. Now, I know some people have done this in the past where they know they have to divide by 4. But I'm going to show you a way that's going to help us a little bit today. I think this is the way most of your teachers taught you in past years. But what I did here was I factored out that 4. All right, so you can ignore the blue here for a second. But this is kind of our key step. Right here, I factored out the 4. And so I was left with x squared plus 5x. And this is where I want to complete the square, just within these parentheses. So factor out the 4. Think about what's left over, and here's where we have to decide what we need to do to complete the square. So just like always at this point, really all we're doing is taking that inside stuff and just completing the square in there. So I took my b value, I divided it by 2, I squared it, and that's how I know that I wanted to add that 25/4 in my parentheses. Now here's the big moment. All right, so hopefully you're thinking back to past math classes. We have to keep our equation balanced. So I'm not just adding 25/4 to this side of my equation. I'm adding 4 times 25/4. So right, if you think back to the first time you learned algebra, you had the little scales, and your teacher said if you add something to one side, you have to add it to the other side to keep your scales balanced. I'm not just adding 25/4 to the side. I'm adding 4 of those 25/4. So to keep my equation balanced, I have to actually add 25 to this other side, right? 4 times 25/4 is 25. So that's how I'm going to keep my equation balanced in this example. Now we can just finish it up. Completing the square, the little shortcut we've talked about, basically whatever you're squaring here, that's what's going to go in your parentheses. So there's my completing the square factoring process, equals 40. And now we can just solve it like I did in the question above, right? Divide both sides by 4. I have x plus 5/2 squared equals 10. Square root both sides. Subtract 5/2. I'll do that kind of in one step. So we have negative 5/2 plus or minus the square root of 10. So there's my answer to this completing the square process. So we're going to use that when we do our vertex form of a parabola. All right, so I'm going to show you a little bit. We'll get some time to practice this next class. But in your notes, here we are on page 10, I think. Maybe the next page, maybe page 10. You're in the right spot. So this is where we can kind of tie it back to the BHAK stuff we learned last class. So whenever you have a quadratic equation, or I guess a function, we can always turn this standard form into vertex form. And so it looks like this. So this should look familiar from last class. This is just a function shifted right h units, vertically stretched by a factor of a, and then shifted up k units. So basically this is shifted over by h and then shifted up by k. So if we're looking to graph this, the vertex would be h comma k. Okay, so hopefully you follow me. The vertex of the parent function is right at 0, 0 here. And then if we're shifting this right h units and up k units, we can also go left or down or, whatever, obviously. That point right there would be h comma k. And the axis of symmetry is x equals h. So it's that vertical line that goes through the vertex that finds your axis of symmetry. So we can always put these into vertex form. All right, a couple little things to remember. The x-intercept is wherever the y value is 0. The y-intercept is where the x value is 0. So I'm going to walk you through one, and then, like I said, we'll get a lot of time to practice this in class. But here's what I'm going to ask you to do. I want you to put this function in a standard vertex form. I want you to find the x-intercepts, the y-intercepts, the vertex, the axis of symmetry, and the maximum minimum value. And then we can even graph if we want. So the only difference here than the question I just did when we were completing the square is this: we don't have a 0 equals. So it's a really big difference. We have f of x equals. It's a very, very important but key difference. But we're going to start the same. So I'm going to add 7 to both sides. But notice I don't lose track of that f of x. I can't just turn that into a 0, and you'll see why in a minute. And then we'll complete the square. So there's no factoring to do here. My a value is already 1. Now I think, okay, what do I need to add to the side? 4 divided by 2 is 2. 2 squared is 4. So piece of cake. My square is completed. Keeping my equation balanced, I have to add 4 to both sides. So I have f of x plus 11 equals, and then we just factor this down. So that becomes x plus 2 times x plus 2. Subtract 11 from both sides. F of x equals x plus 2 squared minus 11. So there we are in standard vertex form. And now we have everything we need to know. If I look at this as a shift left, right, up, down, and my stretches and my shrinks and everything, this is just a shift left 2. So if here's my parent function, x squared. This is just a shift left 2 and down 11. All right, my graph is going to be a little bit weird here, but let's say that's negative 11. So the vertex is at the point negative 2, negative 11. And so my graph would look something like this. All right, we'll worry about the roots in a second. I know that's probably not exact. Maybe I shouldn't have done that. But we now have kind of a picture of what this graph is going to look like. So going through everything I asked you for, the vertex is negative 2, negative 11. The axis of symmetry, again, is this line that goes right through the vertex. It's that vertical line that cuts it in half. The axis of symmetry is x equals negative 2, that vertical line. And what else did I ask you for? The x-intercepts and the y-intercepts, right? So the y-intercept, let's work smarter, not harder here. The y-intercept is when x equals 0. All right. Yeah, I could plug that in down here. So I could put 0 in for x and do a little bit of algebra. But the easiest place I see to find the y-intercept, if I just plug in 0 for my x's here, the y-intercept right there is just staring me right in the face. So the y-intercept is at the point 0, negative 7. So my graph is pretty messy over here. I'm going to delete that. I don't like that. So goodbye. All right. So the y-intercept, if I start kind of like piecing this graph together, is going to be right there about negative 7. And now we can find the x-intercepts. So this is what I meant about working kind of smarter, not harder. If we think back to the example I did right here. This equation was kind of already in that completing the square form. So looking at this example here, I don't need to go back to the beginning. I don't need to go back to here and start from scratch. All right, maybe it's factorable. That would be nice if it was an easily factorable equation, but it's not. So I already have the completing the square process done. If I look at any one of these last couple steps, so remember the x-intercepts happen when y is 0. So my y in this equation is like my f of x, okay? So my y value, when that is 0, that's how I know when the x-intercepts happen. So all I really need to do, if I put 0, I'm going to pick this one here. I'm just going to choose this equation. I'm going to put 0 in for my y. And you can see right here, we're pretty darn close to being done with this equation. So that 0 I can just ignore. So to finish this up, I'm going to solve for x. Take the square root of both sides. I have plus or minus square root 11 equals x plus 2. If I subtract 2 from both sides, I'm going to write it over here because we're pretty much done already. See how easy that was? If I just picked the most convenient spot here to put in 0 for my y, then I'm in good shape. So my x-intercepts are -2 plus or minus square root 11. All right, and I guess I could write that in my ordered pair form just to keep it consistent with the answer above. So we're good, right? Square root of 11 is a little bit over 3. So if I wanted to graph these, -2 plus a little bit more than 3 is a little bit more than 1. So maybe I'll put that root right there. This doesn't have to be perfect, doesn't have to be exact. -2 minus a little bit over 3 is a little bit over -5. So my graph, I know it's kind of skewed because the scaling is messy, but my graph will look something like this. And I'm sorry, I'm doing this on my tablet, so it was a little hard to get through that point, but you know what I mean. Can I grab that? Yeah, okay. So that's a really awful graph, but you got the idea. So that's what I'm going to ask you to do with these vertex form. Put it into vertex form and then kind of think about all the transformations we've learned. Find the x-intercepts, find the y-intercepts, and then roughly sketch a graph. So let me see how much time I've taken up already. Okay, so we're at 12 minutes. I think I'm going to stop now. We'll have plenty of time in class to practice these. If you want to try this one out on your own, there's a little more going on. Maybe I'll get you set up, and then if you want to mess around with this, you can, and we'll talk about this when we come to class next time. So the first thing we're going to do, like I said, is subtract that 7 from both sides. Okay, so now we're here. This one we do have a little bit of a more challenge on our hands because we have that a value is -4. So what we need to do is factor out that a value. So we're left with x squared minus 6x. Careful here. Okay, so I guess one more note. I didn't factor out the x. We need that x and the x squared to stay in our parentheses in order to complete the square with. So keep that in mind. And now we have our blank here. So I'm going to let you guys kind of pick up from here. We'll get into this next class. See if you can finish this up. At the very least, get it into vertex form, and then we'll finish these examples up together next class. All right. So let me know if you have any questions. I will talk to you guys soon. Have a good night. Bye.